So I was invited to give a talk about Vim, and it's always the question like, okay, what am I going to talk about? So I'm going to mix some things, some history, some recent developments, and I also think that I guess most people here will be using Vim. Can you show your hands? Who's actually using Vim? Okay, that's most of you. So besides Vim, I will also talk a bit about, if you run your own open source project, how to make it successful. So let's see where this goes. First of all, a slide about, what has happened to Vim over the years. Has become more popular, did people run away? So can you guess what the lines mean here? So there's a blue one that's almost straight, and a red one that's going down, and a yellow one that's almost nothing happening. So I'll tell you. So actually the line going down is Emacs. So I'm quite happy about that. You can see that Vim is basically stable. It's, people just use it. And this is actually not number of users. This is more like people asking questions, people that search for information. And the yellow line is NeoVim. That's a fork of Vim. Started not so long ago and didn't really catch on yet. All right, so what has happened to Vim over the years? Well, it has been growing, clearly. At first, pretty slowly. In the middle, there was a big flurry of new features, and a lot of code got added, and currently it's gradually growing. Now, when you decide to add a feature to something like an editor, there's so many things you could do. There's so many things you could change, improve, add, and it's like, how are you going to decide? How am I going to decide what to do next? Well, I sort of have some ideas about it. First of all, what you're going to do has to have an impact. So it's not something that, will not make any difference. Like, if I clean up the code, just make the code look nicer, users won't have any profit from that, not right away anyway. So have a basic rule like everything you do has to have an effect in like a couple of months. There was another editor called Elvis that was actually a competitor to Vim a long time ago. The author of Elvis actually decided that his code was ugly, and he spent like 2 years just cleaning up the code. And in the end, the editor, the code was doing the same thing. And do you still hear about Elvis? Not much, really. So if you're going to do something, change your code, make it better, do something within a couple of months. If it takes longer, it will never be effective. Another thing is do one thing at a time and do it well. This has been said many times, but it's really true. And also, if you think like, oh, this is a lot of work, try to break it up into pieces, and each piece should be useful by itself. This is actually quite tricky, but you'll figure out a way to do that. And third of all, and probably the most important, understand your users. For me, it's easy because I use Vim myself, so I understand myself, usually. And you have to decide like, okay, what am I actually going to enjoy when I add it? And I talk to users. It's a bit tricky because quite often people can be very vocal about something they want or they don't want, they don't like. And you have to balance that against what you think the rest of the world wants. So, how did this work for Vim? So I'll give some examples. In the very early days of Vim, it was running on Amiga, a very nice computer at the time, had colors, was not obvious at that time, and I started working on Vim back then. And after the first release, the question is, what's going to be the next step? Well, first of all, you need to have an impact. You have a need for more users. How do you find more users? Well, on the Amiga, it was pretty limited. So a port to Unix and a port to MS-DOS, Windows didn't exist yet, helped to find more audience, especially to Unix, which was a bit weird because VI originally comes from Unix. I made a port on the Amiga, and now it was going back to Unix, and now it's competing with the original, which is quite funny. More users is always good, more attention, more developers. That's the way to go. So the next release, Vim 2, I was wondering, like, how I make users more productive. And one of the things was the original Vim already had a way to build and find errors. But it was very specific for one or two compilers. So in Vim 2, I said, okay, let's make it more generic. So you could actually specify the format of your errors, which means it works for just about any compiler. And that makes your work, editing, compiling, fixing problems, a lot more efficient. The next thing is, again, more users, more people who like Vim, was to make it more VI compatible. A lot of distributions were either shipping with the original VI, which is really, really old and nobody maintains it, or some other clone. And when they have to decide, okay, which version of VI clone shall we put on our system, and that's for Linux distributions, for Mac, other systems, they say, well, it has to be VI compatible. So around that time, I spent quite a lot of time to actually make Vim completely VI compatible, except for a few bugs. And this worked really well. So by now, just about any Linux distribution has Vim, and also it's on every Mac. Although a lot of Mac users don't even know what Vim is, but it's still there. Vim 3. At the time, there was a competitor coming up called NVI, and this was the work of Keith Bostich. As you know, maybe that the original VI was part of System 5, Unix distribution, and it was proprietary software. So nobody could actually get the source code and do something with it. And they asked many times, but the owners of the code were not willing to give it away. They thought they could make money from it somehow. So Keith Bostich said, okay, let me recreate it and make an open source version of it. And not only did he do that, he also added some new features, and one of them was make it possible to have more than one window, so split windows, and editing several buffers. And I looked at it like, wow, that's a good idea. I think I would like to have that as well. I actually tried to work together with Keith, but he was very much doing his own thing. And so I said, okay, then I'll do it myself and add this to Vim. Of course, this was only possible because at the time, computers were getting much faster and had a lot more memory. And if you have multiple windows, you need more memory. Also, screens got bigger. So you can actually make split windows, because if you only have 24 lines of text, you can't do much. Okay, another thing is reliability. If you have a program like a text editor where people spend a lot of time putting in new things, they don't like to lose their work, obviously. So if your computer crashes, if Vim crashes, never happens, of course, you want to make sure that people don't lose their work. So I made the swap file, it's called, so all your work is stored on disk. Every so many seconds it creates a snapshot, and whatever happens, you can always recover your work. So that's user trust, something that people say, I can trust this program, I can live with it. That's very important. Gradually, more and more features got added. I think one of the main problems with adding new features is people don't understand how they work. So today you would probably go on the internet and search for anything you want to do. Back then, there was no internet yet, so I decided to build a help system inside Vim. And going back to the start, building a feature on top of another one, we now had multiple windows. So we can put the help in a separate window. So you can open help, look at it, close it again, and continue your work. So that's a good example of how you build one feature on top of another one. Extensibility. I was trying to implement all the features in C code myself, using patches from lots of people, but there's a limit of how much you can do in the actual code. You need some way of allowing people to extend it and add their own stuff. So auto commands were added where you have events at specific moments and you can trigger a command. And this, unfortunately, I actually regret adding this by now because it's too powerful. You can very easily break your own stuff. You can break Vim. A lot of crashing bugs have been caused by auto commands. So if I would do it again, I would do it in some other way. But anyway, it's a very powerful feature, and you can build on top of it. I'll come back to that later. Another thing is actually there wasn't a good Windows port yet. So there was MS-DOS, but that's, you know, in the console window. It's very limited. And a lot of users are actually on Windows. I don't know what you're usually running on your computer. These days, a lot of students run Linux or even have a Mac. But most people in the world are running MS Windows. And so having an MS Windows port of Vim was very important. Fortunately, a few people started creating it. I didn't do much of this work myself. I don't really like Windows. So anyway, it got done, and it means that a lot more people can use Vim now. Syntax highlighting. Actually, many people think it was there from the start, but no, it got added at some point, Vim 5. Why? Because it takes a lot of the computer, requires a lot of CPU cycles, requires a lot of the screen updating, has to be fast, otherwise you can't get the colors. And actually you need color support because the first Amiga only had like 16 colors. It's not much really. And these days, of course, you have like 60 million colors, so that's much better. Syntax highlighting helps a lot to understand your code, even spot errors while typing it. So that's a very nice feature. Vim 5 also added Vim script. Before it was just some commands you could use, but now we have like a for loop, an if statement, expressions, and all those things. So you can actually write a script almost like a programming language. Vim script is not something that was designed from the start. It's more like an organic growth that every time we thought, it would be nice to have this statement or this expression, I just added something that I thought would be nice at the time, and worked out quite well. Growing over time, computers started with even just capital letters. At some time, a standardization committee said, let's define these 127 characters, so that's called ASCII. But that's a long time ago. Like in Polish, you have so many different characters that don't fit in ASCII, and there were all kinds of different encodings, and the Unicode committee got together and finally decided, okay, this is the code that everybody can use, and I actually wasn't aware of it at first, but some people told me, oh, you really have to support Unicode, especially UTF-8 as the encoding, and this happened. This was actually a lot of work. It's not so easy to implement this, especially because before this, before Unicode, we did have support for multi-byte characters, especially Japanese, Chinese, and those encodings. And then switching to Unicode is quite a big step. Vim 6 only then got automatic indenting added. Before this, there was like C indenting, which was again coded in C, and it's very difficult to extend. So since we now have Vim script, again, something building one feature on top of another one, if we have Vim script, you can write a Vim script to do the auto indenting. And now it's all automatic. So keep in mind, if you build something for users, users are quite lazy, especially software developers are very lazy. And if they can automate something, they want to do that. So automatic indenting is one of those. Plugins, again, we have Vim script, we have auto commands, and then from that grows plugins. So you can actually just get a file that does something useful, drop it in your plugin directory, and use it. Building blocks, and these days there's, I don't know, thousands of Vim plugins that people use. So this was very popular. Vim 7, I think if you remember the first graph of the growth, now we're getting to the part where it slowly keeps growing. So around this time, a lot of little things got fixed, got added. And it's actually hard in Vim 7 to pull something out, say this is a very important or impactful change. I think persistent undo is the one that I would pick from all of those. I use it myself a lot, because now you can actually edit a file, make all kinds of changes, close your computer, go home, come back to work the next day, and you say, oh wait, that was wrong. And you can open the file again and undo back to the history, back in time, and then you can say, no, that was right, and go back forward again. And that's because the undo information is stored in a file, and it's still optional. I wonder how many people actually use this. I've encountered several people, including Sven Guckes. I don't know if you've heard of him. He's very active in the Vim community. That this is actually something that works and can save your time, because if you don't know about it, you think, oh, I have to type it again. But no, you can just undo or redo, whatever you like. Okay. So the last major version that got out was Vim 8. And Vim 8 actually had quite a bit of functionality around asynchronous behavior. So jobs, which are processes running outside of Vim, channels to talk to those jobs, and timers to do polling or whatever you need. So it's all asynchronous kind of stuff. And people have asked for this for a long time, but I always thought like, that's really a big piece of functionality, so I've been postponing this, but at Vim 8 finally it got included. Again, the reason to include it is that plugins become more and more complex, and just doing this in Vim script inside Vim is not enough. So people want to start another process, for example, a lint program to check the code, or even compile something in the background, or do some very complex autocompletion. And for that, you need jobs and channels, etc. Okay, that's the biggest release we had for a long time. And then the question is, okay, what next? After all this, what is the next feature to add? So, looking at the list of requests from different people, and especially what I wanted myself is a terminal window. Okay, something wrong. Okay. That's actually when I made a decision of what to add. I'm a bit selfish here, because why did I want to add this? Because I wanted to debug Vim while I'm traveling. Like now, I'm away from home, and at home is my main workstation, and I want to SSH back into that system and debug Vim. So what do I need for that? First of all, I want to run GDB. That is the debugger I use. I want to see that program being debugged, which is Vim. And actually, Vim has to run in a separate window. Sometimes you can run GDB and have the program run in the GDB window. With Vim, that doesn't work, because they're competing over the input. And then, of course, you want to have a look at the source code at the same time, so you can step through it. So this is what I would like to make. In the top left, you see GDB. So that's a window on GDB running, so you can tell it to show the stack, set breakpoints, watch points, etc., everything that GDB can do. In the top, the bottom left, you see Vim running, and it's really Vim in a window, in a terminal emulator, so it behaves like normal Vim. And on the right, it's the source code. So you can look at the source code. The pink area is a pop-up, a balloon, that shows the status of a variable. And at the top, you have what I call the window toolbar with some buttons you can click on. The reason to have buttons and menus and stuff like this is because with key commands, it's actually quite difficult to navigate through 3 windows. While if you use the mouse, you can just click, and it's a lot easier and quicker. So mouse support is essential here. So what do we need for this? First of all, we need a terminal emulator. Fortunately, libvterm is available, and it's pretty good. It's written in C, and I had to make some small modifications, but otherwise it's just working. We need to be able to run GDB, run the program that's being tested. So you need jobs and channels for communication. That's another feature we built on top of another feature. We have that. Like I mentioned, I wanted to have a toolbar where you can just click, step, and next, and finish. That didn't exist yet. So I decided to add that. And then we need a balloon to show the content of a variable. Well, that existed in the GUI in GVim, but it never existed in the terminal, so I had to build that as well. And a pop-up menu, again, in the terminal. So we need those parts. So how are we going to put this all together to make it work? First of all, even though libvterm is a piece of code, it runs inside of Vim. And Vim is single-threaded. That's good to remember, keep in mind. And then you have the job, which in this case is actually GDB. That's running external from Vim. And also if GDB starts Vim, that's another program that runs externally. But you don't talk with it directly. So inside Vim, the main code, you have the window toolbar, where you can click on things. You have the balloon, so if you move the mouse and you hold it somewhere, it pops up the balloon. And you have the pop-up menu, which is a right button click. It all sounds very simple, but it still has to be implemented. And then it talks to libvterm, so that's a third-party library that Vim talks to. It's actually part of Vim, but there's still a very well-defined API that you use. And then, of course, you need the channel to talk with the job. So let's go into more details and see how this really works. So let's start with step 1. The user presses a key. Let's say it's the down key. And Vim decodes whatever the key was typed. And then it calls a vterm function called vterm key down, obviously. And then vterm says, okay, in this terminal, the key down is escape OB. So that's an escape sequence. Then Vim reads that back and says, okay, now it's just a bunch of bytes. I don't know what they mean. I'm going to send them to the job. So over the channel, it sends it to the job, where the job will say, oh, that's key down. Changes whatever it changes, and eventually, after some work being done, it updates the screen. Well, updates the screen, it sends bytes to what it thinks the terminal is. And actually, Vim is waiting for those bytes. So it gets some bytes from the job. It says, Vim doesn't know what they mean. So the bytes are written to vterm. And vterm says, these are escape sequences that update the state of the terminal. So it will update its internal state, the screen, what's displayed, and whatever else. And then it invokes callbacks, which then tells Vim to update the screen. So you can see vterm only has internal state. It doesn't actually display anything. And Vim takes care of the displaying, updating, the terminal, etc. libvterm will eventually say, okay, this was it, this is all the updates. and then Vim will redraw the display. So what will also happen is that the job will just come up with some things to be done. Without any key input, without anything, it will just say, hey, here's some things I want you to display. So Vim is always waiting for input from the job, and again what happens is it reads it from the job, sends it to libvterm, and again displays the output. So the example here is to just move the cursor, which should be fairly simple. Okay. Now I hope I managed to do a live demo. Let's see if that actually works. So I'm now SSH into my home system. Let me try to run Vim. That part works. Now I want to start the terminal debugger. Oops. And I want to debug Vim itself. It's not working well. Okay, you can't really see what I'm showing. I think it's not the connection. No, okay. Let me go back to the presentation, that should work better. So this one works, right? Yeah. Okay, sorry, live demo is cancelled, I can't really. It's also white, yeah, that's, it should be the same, I don't know why it doesn't work, but I have some screenshots, so it's not live, it's simulated live. Yeah, but this is the presentation, that's not live. Okay, so just imagine I'm typing this live, but it's not actually happening. So once you start term debug Vim, then you see this. So this is the empty state. Again, top left is GDB. The bottom left, that's where the program will run, and on the right, you just have Vim editing source code. So I can go into, sorry, this is, yeah, I'm looking at some source code, and then I can say, I want to break somewhere. So I'm going to debug some statements, and I use the pop-up menu to set a breakpoint. And then on the left, when Vim is running, I type the command help GUI. And so this is actually typed. And then I hit the breakpoint. So now in the source code window, I can step through the code using the window toolbar at the top. So pressing next, etc. And using the balloon, so I can hover over, for example, oops, I shouldn't press a button, EAP, and which is a structure, and then it shows the content of that structure. Of course, you can also go to GDB and print any variables there, but of course, hovering with the mouse is much quicker, much more efficient. So this is how you use the debugger, and this, of course, doesn't only work with Vim, but you can debug any program, step through it, set breakpoints, etc., etc. So this is very useful. Now, okay, so I made all these pieces to be able to build a terminal debugger. So what else can you do with those pieces? Well, for example, you can just start a terminal and run make or any other program, and it will do its thing while in another window you can keep editing. So it's asynchronous. Actually, somebody already made a plugin that while make is running, it will collect any errors, and you can jump to those errors even before make is finished. So that's quite nice. Also, the GUI so far, and the GUI runs in a separate window with GTK or on MS Windows. So far, if you typed an external command, it would use a dumb terminal. Basically, you can only list things. But now we have a real terminal emulator. So now you can actually get colors in your terminal. So you can type any command like ls or cat or whatever, and it's even possible to run Vim inside of Vim. So I'm not sure if that's useful, but you can do it. Another thing is testing. Now, the more code you write, the more mistakes you make, the more things break, and the more testing you will need. So one thing that's called added with the terminal window is you can actually take a screenshot of a terminal. And before you could do this with pixels, but then every system shows a terminal in a different way. So just actually taking a real screenshot wouldn't work, because it would work on one system, but on another system it would be different. But you can take a screenshot of a terminal which just shows the colors, the text, but not the pixels. And so in this example you see a screenshot at the top and one at the bottom, and in the middle is the difference between them. So you can see what happened. So let's go back a little bit in what happens with testing with Vim. In the early days there were no tests at all. You know, I just wrote some code, see if it worked, and that's it. Of course that doesn't scale if your program gets bigger. So at some point I actually wrote some tests, which were basically commands that you type. It's not even a Vim script, it's really the commands that you type. And it would maybe source something, do some settings, search for something, and then some command. And then write it to test.out, do some more stuff, and again write it or append it to test.out. And then this test.out file you would compare to the OK file, which is the expected output. And then if there's any difference, then it's a big puzzle what went wrong. So it does do a proper test. It does some stuff, checks that the output is correct. But when things are wrong, it's very difficult to debug and find out what went wrong and why, especially if the text keeps growing. The tests, you know, especially the Python tests are just huge. And then you find some error message is not happening, or an exception shows up in a different way. And then you have to, you know, go into the puzzle and find out why that happens, which is very difficult. So at some point I decided we need some other kind of testing, which is actually using asserts. So this is what most programs do, most languages. And so this is just Vim script. And it's pretty easy to read. So you say, okay, let me set some lines. So you open a new window, set some text in that window. It's just 4 lines with characters. And then you say, okay, let me move the cursor around and then check that it's actually at the right position. I think that's fairly easy to understand what's happening here. So you have these asserts to say it's equal. And suppose one of these asserts say, hey, this is wrong. I expected this, but I got that. Then immediately you know, because it also says the line number, you can go there and say, hey, what happened there? And if it's not immediately clear, then you can go back to your debugger and set some breakpoints and say, okay, if this happens, what happens exactly? And you can do your debugging. So this actually makes testing Vim a lot better, a lot simpler. And unfortunately, there's still some old style tests around. Gradually, we're converting them into new style tests. This will still take some time. In the meantime, it will keep working. Now, this is a lot of checking. So you do something and you have an assert to check that it's there. This works really well for normal commands and output. But what if you want to look at the screen? For example, a pop-up or a menu or something like that, something that's very interactive. That's actually very hard to do this way. So that's where the terminal debugger window comes in. So you basically want to take a screenshot, or better, a terminal shot, dump of the terminal. So this test is a new style test, but it has a few special things. First of all, it checks if you can actually open a terminal, because the feature is not always there. And then it writes a file into xtest. And then it starts Vim in a terminal on that file. So it says, run Vim on that file. So this is what will be displayed in Vim. And then it sends some keys that says split. So a vertical split. So then you have two windows. And it sends some keys, and in this case, it's go to the end, append, and Control-N is autocomplete in the next. So it does an autocomplete, which then opens a pop-up menu. And then what happens is, you actually create the dump here. So you trigger the pop-up menu, and then you say, okay, now I want to see what it looks like. And you give the name of the dump, and maybe some arguments like I only need 8 rows of the dump. And then, when the test fails, it says, well, I expected this screen dump, but I got this screen dump. And then you can look at the difference and wonder, like, what happened there? So, well, it turns out that there's a B here and an A there, so you have to figure out what happened there. I actually intentionally broke the test just to be able to make the screenshot. So this helps a lot for interactive commands that you want to debug and make sure that they work and keep working. Especially these pop-ups, these autocomplete things that go on top of everything else. It's almost impossible to debug this and test this in any other way. All right. Okay, we went through it pretty quick. So all this is still being finished. The terminal window feature is almost done. I would like to fix a few more things. The features are now almost complete. There's still a few bugs to fix. And we'll do that really soon. So hopefully in a few weeks, I can make the Vim 8.1 release. Okay, that's all I had to say. So I'm open for questions.